Every trade, profession, and technical area has a huge language that must be understood in order to communicate effectively within that area. This language may include words, phrases, and symbols. The basic means of communicating the language of control is through the use of the ladder diagram, sometimes called a line diagram. The ladder diagram consists of a series of symbols interconnected by lines to indicate the flow of current through a variety of devices. This ladder diagram tells us in a very short manner through a series of relationships what would take many words to explain. The diagram shown above tells us basically two things. 1. The power source, the lines that are drawn vertically. 2. How current flows through the various parts of the control circuit. This includes push buttons, contacts, coils, and overloads. Ladder diagrams are designed to show only the parts of the circuit that are used in the operation of the controller. It does not and is not intended to show the physical locations or relationships of the various components of the controller. The ladder diagram is a simplified diagram showing only the control circuit. A variety of symbols are necessary to effectively communicate the operation of the circuit. Many of the most common symbols will be shown on this screen and the screens that follow. Keep in mind that each situation may require variations of these symbols. Also remember that even though there are ANSI standards for these symbols, not all drawings will follow the standards. A competent technician will learn to discern the meaning of a symbol through careful analyzation. A three-wire control uses a normally open, momentarily operated start button and a normally closed, momentarily operated stop button. It also employs the use of a set of normally open auxiliary contacts. These auxiliary contacts are used to interlock the circuit or seal it in. These contacts are sometimes referred to as memory contacts. When the start button is pressed, current will flow to the coil of the motor starter. As the coil energizes and pulls the armature to close the main contacts, the auxiliary contacts will also close. This action will allow current to flow around the start button that was momentarily closed. The circuit is now sealed in. By operating the stop button, the flow of current to the coil is interrupted and the magnetic field collapses, allowing the armature to return to its at-rest position. This return to the at-rest position is accomplished by spring tension. With the armature at rest, the auxiliary contacts are opened and the seal-in is lost. The motor starter is now de-energized. A timing relay is similar to a control relay with one exception. Some or all of its contacts are designed to operate at adjustable intervals or lags after the control is energized. Time delay logic is an important function of control circuits. It allows a circuit to pace itself. Basically, there are three types of timing relays: dashpot timers, synchronous clock timers, and electric timers. All of these accomplish the same task, but they accomplish it by different methods. There are two categories of time delay logic. They are on-delay logic and off-delay logic. The on delay is designed to activate its contacts after a preset time has elapsed. The timer coil must be energized to begin the timing period. An on-delay timer will have two types of contacts: normally open timed closed and normally closed timed open. The off delay is designed to operate its contacts in response to the closure of an initiating switch. Closing the switch will cause its normally open contacts to close instantly, and its normally closed contacts will open instantly. As long as the initiating switch remains closed, the contacts will remain in their active state. Opening the initiating switch will begin the timing sequence. After the time lag, the contacts will return to their normal state. Off-delay relays will have normally closed, timed closed, and normally open, timed open contacts. The diagram shown above is a typical application for an on-delay timer. When the start button is pressed, both the control relay and the timing relay are energized. The control relay is necessary to accomplish seal-in. When the timing relay times out, the normally open timed close contacts will close and energize the coil of the motor starter.